Hi, today I will show you how to determine the middle node of a double linked list. By the end of today's conversation, you will have seen 3 different approaches for solving this kind of problem. Let's get started. In this problem, we're given the following double linked list. What does double mean in this situation? It means that we can travel both forwards and backwards. As you see here, we have the arrows that go both way. So here, you can go both to D, but then you can also go back to C as well. So that's really important to note. Another thing that's really important is that we are referring to a linked list. And to kind of reiterate that same point, we can't just jump to a certain node. We don't have any indices here. This is not an array. This is not a regular Python list. Therefore, we cannot just jump to a particular index. In fact, linked lists have no indices. What linked lists do have is that they have nodes, and then these nodes have pointers to other nodes. So that's a really important distinction to mention in the very beginning. Now, we're being asked to find the middle node. As mentioned before, we have 3 different approaches. The first approach is brute force. And I think that out of all 3 approaches, that this is the most intuitive. The first step is to count the number of nodes. In this situation, we will do 1, 2, 3, 4, 5, 6, and 7. So in this case, we have 7 as the number of nodes. Next, we will calculate the middle by dividing the total number by 2. That is step 2. Calculate the middle. All right, so how does this work? What we do here is that we take the number from the previous step, which is step 1, and then we simply divide this by 2. So we get 7 divided by 2. This is going to give us 3.5. Now, the first thing that you may notice here is that 3.5 is not an integer, right? It doesn't fit into here. We have 1, 2, 3, 4, and all the way to 7. So 3.5 is somewhere between 3 and 4. What you want to know is, the rule that you want to follow in this case is that you always want to stop after you've passed the middle. So this is really great because it works for when you have an odd number of items, and then it also works for when you have an even number of items. The next step is to iterate until you have passed the calculated middle. So iterate until you've passed 3.5. All right, so in this case, the calculated middle that we have is 3.5, and we can kind of just go here and demonstrate the iterator. So here we have A, which is 1, B, which is 2, C, which is 3. 3.5 is somewhere between C and D. So we jump to D, and then we realize that, hey, we have the 4th item, and this is more than 3.5. Therefore, we would declare our middle as D. And that is how the very first method works. Now, again, this is for an odd number of items. And the beauty of this approach is that this will still work if you had an even number of items. If you had 6 items per se, you would do 6 divided by 2. That would give you 3. And then you would end up still stopping at the 4th. Whenever you have an even number of items, you have to take either the item which is left of the middle or to the right. I recommend taking the item to the right because it's simpler. It works for both the odd case and the even case, but it's really a preference. It's more like a convention. So this is brute force. The next approach is to The next approach is to iterate from both ends. And this is a pretty cool approach because we have two different iterators. We have an iterator that starts on the left side here, the start. Let's refer to the left as the start. So we have an iterator that starts at the beginning. And then we have an iterator that starts at the very end. The one which starts at the very end is going backwards. So you're actually moving to this way. And you can do that because, again, this is a double linked list. And then the iterator that is starting at the very beginning is moving forward. So let's call the one which is moving forward F, and we'll call the one which is moving backwards B. So the very first step is to really, you kind of have two things happening in the first step. So you can just really say there really is just one step. So you're repeating the same step over and over and over again. And then anytime you increment, you simply check a condition. When the condition is met, then you have reached the middle. So that is the process here. So step one, we'll say iterate F plus 1. So you move forward. And then at the same time, you will iterate B minus 1. So you're moving backwards. Now, when do you stop? You will stop. So this is your condition. You will stop when both F and B are at the same node. So let's kind of look at this example here. What I'm going to do here is I'm going to write down the values that we get for F. So as we're moving from A all the way to G, I'm going to write these values down. So we'll have A, and then you'll encounter B, then you'll encounter C, D, E, and G, right? Now, if you're starting here with this iterator that's going backwards, we're doing everything backwards. So you first start at G, right? Then you go to F, then you go to E, then you go to D, then you go to C and B and A. All right, so what do you notice here? You'll notice that at some point, the forward iterator and backward iterator will overlap at the very same node. When that happens, you can actually stop. So you don't really need to go all the way. In fact, you can stop at the very middle. And that is really the beauty of this approach. You really iterate until you are at the same node. The third approach is to use a slow and fast iterator. So in this approach, we will increment from the left side, and we have F, that is our fast iterator, and then we have S for our slow iterator. And similar to the previous approach, this approach only has one step. The fast iterator is incrementing by 2 every single time. So we plus 2, and the slow iterator is incrementing by 1. So what do I mean by that? So with the slow, that means that when we iterate by 1 or increment by 1, we go from A to B plus 1, right? And then we go from B to C, we go only 1, C to D, and then so forth. Now the fast iterator, we will be skipping 2 items. So we go from A, we skip B, go all the way to C, right? This is plus 2. We go from C, skip D, go all the way to E, and then we go from E, skip F all the way to G. And that is really the differences between the two. Now, here's the beauty of this approach. The beauty is that because the fast iterator is going twice as fast, by the time the fast iterator gets to the end or passes the end, so that's really important, it either gets to the end or passes the end, by the time that happens, the slow iterator will be at the middle. So that's really the crux of this approach. For example, in this example, and I'm going to write down the steps here, If we're looking at the fast iterator, we'll go from A to B to C, D. Actually, this is not the fast. This is actually the slow. So let's say this is a slow iterator. We go from A, B, C, D, and we will go to F and then G. Now the fast iterator, again, we're skipping 2 items every single time. We go from A to C, from C to E, and then from E all the way to G, right? So by the time the fast iterator gets to the end, you'll notice that the slow iterator is in the middle. And that is really the beauty of this approach. And that's it. So thank you for watching. If you have any comments or questions, please leave this in the comment section. Thank you.